Hi, my name is John Capobianco and I'm a product marketing evangelist here at Selector AI. Today, in the Trends in AI series, we're going to be exploring agentic artificial intelligence, agents. And I think to really demonstrate the power and the capability, and at this point, the promise of agents and agentic AI, I'm going to give you a live demonstration on how we can use natural language to chat with a router. And we're just going to use human phrases, and the router, the code itself, the agent itself, is going to have access to Python functions and Python code and be able to act autonomously. The approach I'm going to use is known as ReAct, reasoning and action. So if we focus on the reasoning, when someone asks a question about, say, a network function, what is my default route? What is the IP address of some interface? Can I get a table of MAC addresses? The AI is going to reason and first pick a command from a list of supported pyATS parser commands. So there's like 3,500, 3,600 supported show commands that have a parser. Now the parser is going to return JavaScript object notation, structured text, to help the AI and the LLM answer the original question. But we can chain these tools and this reasoning together. Do I need a tool to help me answer this question? Yes. Here's a list of valid tools. It picks a valid command. Now that it has a valid command, it can pass that along to the next tool in its chain, which actually executes the command and gets the JSON. Finally, we get a natural language answer back from the ReAct, reasoning and action, pick the appropriate parsed command and act upon it, run the function, to then get the JSON to answer the question. You're going to see this in action, and it's going to be a lot more palatable for you to understand. But we're going to explore the world of agentic AI today and a next evolutionary phase of the artificial intelligence inflection point. Thank you. So if we do a search for agentic AI in Google and look at news results, we're going to see all kinds of incredible documentation and positions and theories and ideas and papers. So the CEO of NVIDIA, right, see gigantic opportunity for agentic AI, spectacular and surprising and moving faster and faster and getting into a flywheel zone. The dawn of autonomous intelligence. Forbes, the next big breakthrough that's transforming business and technology, agentic AI. AI agents, the new workforce we're not quite ready for. AI isn't magic, but can it be agentic, from the New York Times? Right? I could keep going, and we're going to see how the world is adopting AI agents. So let's get into it today. The first thing I want to point out again is the reasoning, acting in language models. So this is taking chain of thought and action only, something like WebGPT, and combining them. So we're going to have reasoning traces and actions that lead to observations. There is some wonderful information here. There is links to the white paper, the code, the blog post. Everything you need to know about ReAct is here on react-lm github.io. Okay, so do your homework and look into this ReAct process. Now this is another paper here that just shows it a little bit differently and some of the metrics and acknowledgments. Now Langchain, an open source AI framework, has ReAct libraries and agent executors and agents, ReAct agents, that we can tap into. So I'm using Langchain code in my implementation here. And finally, how does this really work under the hood? So we're going to have the original question. What is my default route? The original thought is, do I need to use a tool? And then the action is going to be invoke that tool. The first tool is going to be to get a valid show command to help answer the original question. Next, now that we have the command, we're going to take another action and actually execute the command to get JavaScript object notation back from the router. Now we can make observations on this. Now this whole thing is an iterative process. It may need to do this 2 or 3 times or 5 times until it comes to a final answer. Now all of my code is on GitHub, and I'll share the link in the repository here, but let's test this out. Now what I'm going to do is first I'm going to try, let's do what are my access list names. Something to do with the access control lists. So if I go under the hood here, we can see we're entering an executor chain. And don't worry, I will cover the code in a minute. Let's just watch it in action first. So what you can see here is that, do I need to use a tool is the thought. It says yes. So check the supported command tools, and I'm looking to see if show IP access list is a valid command. That function, that tool, does say this is the supported command. So then it says a follow-up thought, do I need to use a tool? Yes. Let's run the show command, passing it show IP access lists. So again, we invoke the reasoning that it knows it needs to check the list of tools, which checks access list. But because of my logic, and I'll show you the logic in a minute, the closest answer is lists. So now it's going to run show IP access lists, which is a valid pyATS command, meaning it has a parser for that command. Here's the command at the CLI. The blue is the JavaScript object notation. Now the follow-up thought is, do I need to use a tool? No, it does not, because of the JSON payload it has access to. The full answer is, here's the names. And as you can see, there's 1, 2, 3 access lists, and there is NatACL, test, and the Meraki. So let's try another question. How about, what is the IP address of Gigabit Ethernet 1? And we're going to run this question. So now, do I need a tool? Yes. Let's try show IP interface Gigabit 1. Here's the closest supported command. So it's going to run the show IP interface brief command. Now here comes back with the IP addresses to get the answer of what is the IP address here. And here is the answer. And I want to point out the reasoning here. And it was going to try show IP interface brief Gigabit Ethernet 1. But it notices that the closest supported command is just show IP interface brief. So it actually passes show IP interface brief to the pyATS function, which goes ahead and runs that show IP interface brief. And now we have the IP address of 10.10.20.48, which is the IP address of Gigabit Ethernet 1. Right? So we can ask it quite a few things, and it's going to select the correct parser based on the one tool, the Python function that we provided, and then provide the information using the other tool. Now let's try something else, just to keep proving that it does work. What is the Cisco iOS XE version on the device? And we're going to ask it what the version is. Now again, it may need to look up the command it wants to run. It's going to test show version, and that is the closest command in the supported tools. So it's going to pass show version to the next tool, run the show version command, return the JSON, from the show version command. And now here we can see the answer is 171202 and some other related information about the device. Just with human prompts, with very little code. So speaking of code, let's take a look at how simple this really is to do. The first thing I want to highlight is that it's less than 300 lines of code. I'm using a streamlit.io user interface to provide this web-based graphical user interface. So that takes up a little bit of code. I have my functions. So the other thing, before I get into the functions, the only few things I need to import are Streamlit for the web UI, pyATS full for the full pyATS library, and the Langchain community. I'm actually going to add, right, so in my requirements, pyATS full, Langchain community, Streamlit. Everything else is included. I have a pyATS testbed file here in YAML that has the connectivity requirements like the IP address or DNS name and credentials to get into this router. So then I have some functions. The run the show command. So I'm disallowing some modifiers because I don't want pipes or includes or excludes or begins or anything like that. So we're going to look for modifiers, but then we're going to load the testbed and disqualify any modifiers. We're going to load the testbed, connect to the device with device.connect. And then first thing we're going to do is get the parser for the command and then run that parsed command against the device. Disconnect and return the parsed output from whatever arbitrary command that comes into this function. We're going to load from commands.json, commands.json, all of the thousands and thousands of show commands that are available as a JSON dictionary, just to give access to the next function, the check support for the command that the AI wants to try to run. And we're using some fuzzy matching here. It's not an exact match, but a closest match. Finally, we're going to process that agent response and invoke the executor here. We use the @tool to decorate our two tools that we want to promote access to the agent to. The check supported command tool and the run show command tool, the actual command execution with pyATS function. In this case, I'm using Llama 3.1. This is an open source free model. It's local through Ollama. If I show you here is my Ollama server somewhere, right? And you can see that it's using the API generate to help generate responses using the information gathered from the tools. We promote two tools to our list and render text description for those tools. Now what's really important is this template. And I'm not going to read it to you, but we have guidelines for the agent, how to use the tools for the agent. To use a tool, use the following format. The first tool provides a valid command. You must immediately run the show command tool next without waiting for any other input. Follow the flow like this. And here is an example of the flow. We have the list of tools and then previous conversation history as well as the new input. And AI has a scratch pad for it to do anything it needs to do on a scratch pad to work out the answer. It really is that simple. The next little bit, we have some input variables, our prompt template, and our agent, where we create that ReAct agent with the LLM, the tools, and the prompt template. We finally execute the agent with an agent executor, bringing in the agent that we just defined, the tools that we listed as an array, and we're going to do this with verbosity and error handling. I like to give this a max iteration of 5, maybe 10, in case the reasoning needs to figure out the show command over a few attempts. But give this a hard cap, otherwise this might run away on you. The rest of this code is the Streamlit UI presentation to do this nice web-based UI. So that's the code. It really is about 200 lines of code if you take out the massive template and some functions that are very easy to understand. We may move ahead and adjust this code with another branch to, instead of using Ollama, use ChatGPT O1, for anyone who wants to use their token and pay for the best experience. I may work on that as a next iteration. But for now, this is free and open source. You could start using this today and start understanding AI agents. So let's just check here. Okay. So I'm going to throw away those couple of changes because they're just changes to the testbed. But all of this is ready to go on github.com/automateyournetwork. And if you go to my repositories, it's called ReAct AI Agent for Cisco IOS XE. And everything you need to know is here to get started with this code. So let's come to... So the world of agents are here. What I think is very interesting is that we can reuse existing Python functions and decorate them up as tools and give AI access to them. Meaning, if you have existing NetMiko, pyATS, Ansible, anything that's in a Python function, define JohnsFunction brackets, that can be recycled and redecorated as a tool that the LLM can now tap into and run to perform the function and take the resulting returned output and act upon it. Reasoning and acting. So I've done this with pyATS. I've done it, if you want to look on my YouTube channel, my personal YouTube channel, I've even done this with some other types of agents, talking to web search engines, talking to calculator functions, talking to other open source tools that you can incorporate into your agent. The next thing I'm going to try are REST API agents, where we can turn a request, a Python request, possibly into an agentic AI function and tool. So stay tuned. This is Trends in AI at Selector AI. Please visit selectorai.com. Please subscribe and like. We are trying to make a series out of this to show you some thought leadership and the cutting edge of the possible and the realm of artificial intelligence operations, AIOps. Thank you for joining me again, and we'll see you real soon.